Hello there, and welcome to Dreamy Science. I'm so glad you're here. Maybe your day still lingers in your breath, a little static in your thoughts, a little weight in your shoulders, but now you are entering something softer, something older, a realm not of questions or clocks, but of drifting constellations and slow burning stars. Tonight, we'll wander through the quiet gathering places of the universe, star clusters, gentle spheres of ancient light, cosmic campfires scattered across the sky, each one a lullaby of gravity and time. If these calm explorations help you soften, consider liking and subscribing to the channel. It helps more quiet minds find their way here, one sleepy soul at a time. Now breathe. There's nothing you need to do. Just rest. Just listen. Above you, the stars do not wander alone. They form gentle collectives, small gatherings of light bound by gravity and time. Even in the vastness of the cosmos, solitude is rare. Stars are born together, breathe together, and move through space like glowing siblings. These clusters, some loose and sprawling, others compact and ancient, float like lanterns through the darkness. They are not chaos, but quiet congregation. You may not notice them at first glance, but they wait just beyond the blur of the night sky. Their unity is subtle, their companionship ancient, and though each individual star shines with its own fire, their motions speak of belonging. Like murmurations in slow motion, they drift as one, a stellar flock tracing the contours of gravity's embrace. These gatherings are not loud. They do not call attention to themselves, but if you listen gently, you'll sense the way the sky is never truly alone. Even in silence, the universe assembles itself in clusters, drawn not by force, but by affinity. It is a celestial instinct written deep in the laws of nature to come together softly and remain. A cluster is not just a group. It is a memory of shared birth. Stars born from the same breath of gas, still drifting together across the dark. To be a cluster is to carry the story of origin. These stars remember their beginning, a single cloud collapsing under its own weight, igniting in dozens or hundreds of places. They are not randomly gathered, but bound by a mutual history, etched in motion and chemistry. They carry the same elemental traces, the same soft hues of shared creation. Though millions of years may stretch between then and now, they remain linked not by proximity alone, but by signature, a chemical fingerprint glowing in light. As they wander through the galaxy, they move in quiet unison, like notes from the same song drifting on a breeze. Some will eventually drift apart, but for a while, a long while, they remain near one another, like childhood friends crossing time together. This cohesion is rare and precious in the restless galaxy. It is gravity, yes, but it is also memory. A star cluster is not a coincidence. It is a family, still holding on. Gravity doesn't rush. It holds, softly, like sleep taking your body at the end of a long day. It doesn't yank or force or shout. Instead, it lingers, patient, quiet, inevitable. In a star cluster, gravity is the silent thread that keeps everything woven. Each star feels the presence of the others, not as a burden, but as a whisper pulling it gently toward the center, toward belonging. It is balance in motion, each star tugged slightly in every direction, yet together they find stillness in the swirl. This embrace is delicate. It must be, for if gravity were too strong, the cluster would collapse inward. If too weak, the stars would drift apart. But in this perfect tension, the stars hover, turning slowly through space, held not by chains but by harmony. Even The wildest orbits have an elegance to them, like dancers knowing how to spin without colliding. Over time, gravity will change the shape of the cluster, stretching, loosening, letting some stars go. But it never loses its grace. It adapts, it holds on just enough. And so, like sleep that takes you softly, like the arms that wrap around you without demand, gravity keeps the stars together, not by force, but by care. Some clusters are loose, youthful, bright with new stars. Others are dense and ancient, pressed tight with old light. Open clusters are the brief flickers, shimmering with blue stars, scattered across the spiral arms like blossoms in spring. They are recent gatherings, born in the lush clouds of galactic nurseries. These are the clusters that live fast and fade gently, their stars drifting apart after only a few 100 million years. Then there are the globular clusters, round, compact, and unimaginably old. These are timekeepers, holding on to the past like folded letters from the early universe. Inside, hundreds of thousands of stars crowd together, their light golden, their dance ancient. While open clusters feel like songs still being written, globulars feel like prayers whispered across epochs. Both types tell us something profound, that the universe doesn't form stars alone, but in communities, that even in the vastness, there are patterns, loose and tight, young and old, shaping the sky's rhythm. To look at a cluster is to see the spectrum of cosmic life, the newborn scatterings and the quiet elders, each turning in their own way, each part of the universe's deep and gentle design. In the beginning, a cloud collapsed, and from it, dozens or thousands of stars awakened in the same breath. They did not form alone, but all at once, cradled in the same nursery of dust and gas, warmed by the same collapsing currents. This shared origin ties them, invisibly but surely. Each star carries the same elemental fingerprint, a quiet chemical echo of the cloud that birthed them. Though they may move at different speeds, shine at different intensities, or age at different rates, their foundation is one, and this sameness doesn't just connect them, it stabilizes them. It allows astronomers to read their story, to understand how stars live and die, by comparing siblings born under the same conditions. Even across the eons, their motions whisper of that first breath, that shared ignition. Over time, some stars will drift, some will be pulled by the galaxy's tides, but the memory of that togetherness will linger in their light. Star clusters are not just stellar gatherings. They are living archives of unity, of beginning, of cosmic kinship. And in their soft glow, the sky remembers how it all began. Open clusters scatter like petals on the wind. Their bonds are fragile, but still, they move as one, born in the glowing arms of spiral galaxies. These clusters hold the youngest stars, blue, hot, and full of motion. Their formations are not tightly packed, but relaxed, allowing light and space to drift between them. This looseness makes them vulnerable. The gravitational pull of the galaxy, the passage of nearby stars, even the slow hum of interstellar clouds can unravel their connection. But while they last, open clusters shine brightly, brief dazzling beacons in the sky's canvas. Some contain only a few dozen members, others a few thousand, but all share a common past. The Pleiades and the Hyades are among these, visible to the naked eye, carrying the softness of winter skies and ancient myths. Open clusters live fast and disperse young, yet in that short span, they offer insight into stellar youth, into birth and early evolution. Their light is restless but radiant, like laughter that echoes through a field before the wind takes it away. And when they do fade, they leave behind stars that still remember, drifting solo through the galaxy, but once, not long ago, part of a luminous family. Globular clusters are not just old, they are time, folded. They drift like golden lanterns in the galactic halo. Their stars are packed so tightly that the sky within them glows almost without shadow. Each one is a sphere of stillness, 1,000 suns percolating in unison, suspended in the hush beyond the galactic disk. These clusters are survivors from a time when the universe was still deciding how to shape itself. Many are more than 10 billion years old, older than the Milky Way's spiral arms, older than the dust between stars. They float in the halo above and below the galactic plane, untouched by the constant bustle below. Their roundness is no accident. Gravity pulls them into symmetry, into cohesion. Inside, stars interact gently, exchanging energy, brushing past one another in a slow celestial ballet. No gas remains. No new stars are born. Only the ancient ones linger, burning quietly with the dim amber of age. Their chemistry tells of the early universe, low in heavy metals, high in purity, like fossils of first light. In the vast timeline of galaxies, globular clusters are not chapters but prologues. They are not chaotic. They are composed, balanced, refined by eons. And as they orbit the galactic center in wide looping paths, they carry with them the memory of creation itself, a memory not stored in words, but in the serene constancy of light. They do not change quickly. They endure like wisdom sleeping in the dark. These stars are siblings, born together, aging together, fading together. Each one emerged from the same cosmic womb, a molecular cloud thick with dust, stirred into collapse by time and pressure. Though each star may now blaze with its own brilliance, their origins are bound. Like family, they carry shared traits, etched into their atmospheres and orbits. Their motions trace arcs through the galaxy as if holding hands, tethered by gravity's invisible thread. Some shine blue and hot, others red and slow burning, but all are shaped by the same beginning. In a cluster, stars are not solitary. They evolve in relation to one another. Their proximity allows them to influence each other's fates, exchanging matter, redirecting paths, even merging under the right conditions. Astronomers read these families like diaries in light, learning how stars live, how they change, how they end. A stellar family offers insight that single stars alone cannot reveal. Over time, this family will disperse, gravity will weaken, galactic tides will pull, and the stars will wander. But even when they are no longer close, they will still carry that shared origin, encoded in their light, in their spectra, in the paths they travel. Some may become red giants, others may go supernova, some may become lonely white dwarfs, but for a while they existed as one, a bright warm constellation of kin, and in that closeness, even the stars were not alone. Time wears everything down, even gravity's hold. Slowly, one by one, stars begin to drift. At first, the cluster seems unchanging, a quiet constellation adrift in the galaxy's slow tide, but nothing holds forever. Even in space, where silence rules and motion feels eternal, the gentle hands of time reshape what was once tightly bound. Stars that were born together, that circled together in the shared cradle of a cluster, begin to loosen their grip. One may wander too far and feel the tug of the galaxy more than the pull of its siblings. Another might receive a nudge, a close encounter, a passing motion, and slip silently beyond the threshold. These changes are not sudden. They unfold over millions, even billions of years. A few stars leave, then a few more, until what once glowed as a single luminous knot begins to thin, to fade, to scatter. The cluster becomes a suggestion rather than a presence, its members no longer bound, but still sharing a direction, a velocity, a memory. Traces remain in the galactic sky, long streams of stars, faint and flowing, like the afterglow of a dream. Astronomers can still see the echo of what once was, reading motion like handwriting, decoding the remnants of kinship. And yet, during its time, the cluster was whole, held not just by gravity, but by the slow magic of beginning together. The bond lingers even when stretched across light years, even when all that remains is motion and silence and the shimmer of departure. The galaxy pulls softly, not to destroy, but to scatter. Just as the moon draws tides across Earth's oceans, the Milky Way exerts its own quiet pull on every cluster within it. This force does not crash or break. It whispers, it tugs, it stretches. As a cluster orbits the galactic center, its stars feel this differential pull. The side closer to the galactic core is pulled a little more than the far side. Over vast timescales, this gentle imbalance creates tension, not sudden or violent, but persistent, like a thread being drawn slowly through water. The outermost stars feel it first, their orbits wobbling, shifting, easing outward, until they find themselves no longer held by the cluster's grasp. They become part of the galactic stream, moving onward with the same forward memory, but no longer tethered to the group. It's a process called tidal stripping, and though it sounds harsh, it's as slow and graceful as erosion, a soft chisel working on a marble sculpture of stars. These forces create trails, long filaments of starlight that thread behind and ahead of clusters as they journey through the galaxy. These trails are clues, gentle signatures written across the sky. They are not signs of failure, but of transformation. The way a family grows and changes, even when scattered, the cluster remains for a time, glowing with shared light, even as it lets go, and the stars, once clustered close, now become part of something wider, part of the galaxy itself. You've likely seen them, a small group of stars nestled close, like a shimmer behind the moonlight. The Pleiades glow in winter skies like a memory. They rise softly in the evening, a handful of pale blue lights strung together like a lullaby. To the naked eye, there are 6 or 7, but behind them shimmer hundreds more, hidden by distance, by dust, by the quiet veil of night. The Pleiades are young by cosmic standards, just around 100 million years old, still wrapped in faint gas and dust. They carry the residue of their birth like fog trailing from a dream. Cultures across time and continents have named them, told stories about them, traced myths into their glow. Sailors watch them for signs of safe passage, farmers for the turning of seasons, but beyond the myth lies the science of their gathering, a true open cluster, born in the same collapse, still bound by shared motion. Their stars are hot and blue, burning with youthful energy, but even now, the galaxy tugs gently at their edges. Some members have already begun to drift away, pulled softly from the cradle, and still, from our small place on Earth, they appear eternal, a glittering nest in the cold sky. In telescopes, their light halos with blue reflection, dust catching starlight and scattering it into glow. The Pleiades are not distant strangers. They are a nearby whisper, a reminder that star clusters aren't just deep in space, but sometimes right above you, waiting quietly on the edge of night, wider, older, quieter than the Pleiades. The Hyades stretch across the face of Taurus like a cluster exhaling. They do not call attention to themselves with dazzling light or dense concentration. Instead, they spread calmly across the sky like a sigh held in starlight. The Hyades are the closest open cluster to Earth, and because of their proximity, their shape appears broad, their stars gently spaced. If you've ever looked up at the V shape of Taurus, you've seen them, their pattern framing the bright star Aldebaran, though that one does not belong to them. Unlike the young, mist-wrapped Pleiades, the Hyades are mature. Their stars have grown older, cooler, some already expanding into red giants. They are around 600 million years old, and like a family whose children have grown, their ties are loosening. Some have drifted far, forming a moving group, still siblings in motion, even as distance grows. The Hyades help astronomers measure distances in space, a benchmark for stellar parallax, but more than a tool, they are a gentle echo, a memory of formation, a quiet breath of shared origin. They do not crowd or cling, they flow, relaxed and certain, through the galaxy. Seen from Earth, they offer a moment of recognition, something familiar, something near. In a sky filled with distant wonders, the Hyades feel close, not because of their science, but because of their softness, because they remind us that not all cosmic families are tightly bound. Some simply move together across time and light, slowly letting go. Far above, in the constellation Hercules, a dense sphere of stars turns slowly. Messier 13 holds hundreds of thousands in its grasp. It is a globular cluster, one of the brightest in the northern sky, and yet still faint to the naked eye, like a breath caught in space. Within it, stars crowd close, drawn together in a perfect hush of gravity and time. They move in a quiet ballet, orbiting a shared center, glowing with the dim gold of age. Most of these stars are ancient, older than Earth, older than the Sun, formed before the Milky Way had settled into its familiar spiral. To peer into Messier 13 is to look backward through epochs, into a cradle that has held its shape for billions of years. From Earth, it appears as a smudge, a cotton-soft ball of light, but through a telescope, it becomes a jewel box, thousands of points, each one a star like our own, shining steadily in the dark. This cluster does not rush. It turns on scales of time that defy memory, and in its patience, it reveals the calm of the cosmos. Messier 13 drifts around the galactic halo, high above the disk, rarely disturbed, and yet, within it, countless suns burn on, their light weaving through space like a thread. It is not just a place, it is a rhythm, a structure, a soft engine of time. To imagine yourself there is to feel surrounded, embraced, gently spinning within a golden sea. Near the edge of Sagittarius lies Messier 22, closed by galactic standards, yet still 20 years away at light speed. It hovers just beyond the reach of easy vision, nestled near the soft clouds of the Milky Way's center. Messier 22 is one of the closest globular clusters to Earth, and because of that, one of the most studied. In telescopes, it resolves into thousands of stars, an entire celestial city orbiting as one. Its light is older than our language, its shape older than our mountains, yet it rests there quietly, unhurried, unmoved by the passage of human time. Dust from the galactic center dims it slightly, a veil across its brightness, but within, the stars continue undisturbed, Messier 22 has a calm density, stars packed tightly in its core, but not chaotic. Instead, they drift in measured paths, orbiting a shared history. Some stars have lived here for over 12 billion years. Some may have been formed in later generations, added like quiet voices to a long chorus. There may even be something hidden deeper still, whispers of a black hole, a dark mass anchoring the harmony. But nothing in Messier 22 feels threatening. Its gravity is a soft boundary, a perimeter of togetherness. You could drift there, surrounded by starlight, and never feel alone. It is one of the galaxy's nearer gifts, a reminder that proximity is not always about distance. Sometimes it's about presence, about the closeness of quiet things, turning together in silence, just out of reach, yet somehow always near. In the center of some clusters, stars are packed so tightly, it's hard to imagine emptiness between them. Their light overlaps like breath on glass. Inside the core of a dense cluster, space becomes a crowded room of starlight. Dozens, even hundreds of stars may exist within a single cubic light year, a closeness unimaginable in our quiet part of the galaxy. These stars do not collide, but they come close, tugging softly on one another's paths, curving trajectories like dancers glancing shoulders. The gravitational web here is intricate and constant. Every orbit is influenced by the gentle pull of many neighbors. In this closeness, the sky would never be dark. From any point inside the core, your sky would shimmer with dozens of suns, each casting long shadows and golden hues. The concept of night would dissolve entirely. And yet, even in this density, there is no chaos. The stars do not rage against one another. They sway, they persist, held in balance not by force, but by the quiet give and take of motion over time. These dense cores are some of the most stable regions in the galaxy. They may conceal hidden objects, collapsed stars, neutron cores, perhaps even black holes wrapped in layers of stellar presence. The further inward you imagine yourself floating, the more the cluster seems to hum, not with noise, but with light, with pressure, with warmth. It is a crowded peace, a packed stillness, the kind of closeness that feels safe, wrapped in light, folded in gravity, stars within stars. To drift inside a cluster is to be surrounded, not by one sun, but by many. In the sky of a star cluster, the firmament is never empty. From horizon to horizon, stars burn in every direction, amber, sapphire, ivory. Their light fills the void, not with glare, but with presence, as though the entire cosmos has come closer, wrapped around you in a quiet embrace. You might turn your head and see a giant red star hanging just above your shoulder, or a blue-white sun cresting slowly over a nearby curve of space. No two stars are the same. Some flicker with age, some shine like youth barely contained. They orbit gently, all sharing the same wide path around the galaxy, but their inner rhythms vary. Their lifespans, their temperatures, their histories, and yet they remain together. The view from within a cluster offers a kind of celestial intimacy. You are never alone in your orbit. You are part of a luminous chorus. The dark between them is thin, more suggestion than reality, as if space itself has softened to allow this gathering. Time slows here, not literally, but emotionally. Each star is a slow breath, each orbit a quiet turn. Light overlaps, shadows dissolve. There is no single point of reference, no north or south, only the feeling of being held within a lantern of 1,000 flames. And even though you are drifting, there is no sense of being lost. In this place, with dozens of suns around you, direction matters less than belonging. Starlight doesn't crowd, it weaves. Soft glows layered over one another, like whispers in chorus. In a cluster, light isn't sharp or singular. It folds gently, cascading in quiet layers. Each star adds its voice to the glow, not to outshine, but to harmonize. The result is not brilliance, but texture. Like morning mist, catching beams through the trees, light in a cluster seems to drift, to wrap, to linger. It comes from all directions, warm reds from aging giants, cool blues from youthful suns, golden white from the quiet middle-aged. Shadows become gentle gradients, and nothing is ever fully dark. As you move, the glow shifts with you. One side of your vision deepens into amethyst, another softens into gold. There is no harsh contrast, only continuity. The light pulses not in rhythm, but in presence. Even when you close your eyes, you can feel it, a background warmth, like sunlight beneath the surface of your skin. The stars speak through brightness, but also through silence. Some blink faintly, others remain constant, and between them, space breathes. Light travels across millennia to find you here in this moment of rest. And yet, in a cluster, that journey is short. Light doesn't need to stretch across the cosmos. It simply passes from star to star, like a secret passed gently in a circle. This is not the blaze of noon, nor the pitch of night. This is layered light, quiet, rich, enveloping, a lullaby written in photons, wrapping you from all sides until you feel yourself glowing too. Clusters are not still. They orbit the galaxy in long looping paths, some flat, some wild. A star cluster moves like a lantern carried gently through the dark. Though each star within it spins in its own rhythm, the entire body drifts together, circling the galactic core. Some orbit near the plane of the galaxy, tracing wide spirals through dust and stars. Others take stranger paths, dipping above and below the disk, carving long ellipses like slow comets of starlight. These orbits can take hundreds of millions of years to complete. There is no hurry, only a calm persistence, a shared motion through the galactic tide. From afar, their paths resemble petals unfolding, or the slow spiral of leaves caught in a quiet wind. Gravity shapes their course, but never forces it. Each motion is a result of long histories, ancient collisions, subtle pulls from distant arms. And though these clusters appear serene, their movement writes the story of our galaxy's past. Where they go and how they go tells us who they once were and where they came from. Some may even be visitors, clusters from other galaxies, now adopted by the Milky Way. Still, they orbit in peace, silent voyagers, turning over ages. Imagine standing still while the whole sky turns around you, not in hours or days, but in epochs. That's the rhythm of a cluster's path, slow enough to quiet thought, deep enough to steady the breath, a reminder that even in motion there can be peace, and even in drift there can be belonging. Far above the galactic disk, clusters drift in silence. They are the old ones, circling high in the dark. These are not clusters that bustle in the bright arms of the Milky Way. These are the ones that hover far beyond the disk in the galactic halo, a vast spherical sea of thin stars and near emptiness. They float like ancient lanterns on the outskirts of motion, bound by gravity, but untouched by the crowd. Out here, silence feels deeper. There are no nebulae, no spinning arms, no bright disturbances, only a soft dark, punctuated by the glow of the stars holding their shape for billions of years. The clusters that live here are some of the oldest in existence. They have seen galaxies collide and spiral arms form, and yet they have endured. Their orbits are long and slow, taking them on journeys far from the light. It may be billions of years before they complete a single loop around the galaxy. And in all that time, they drift in quiet harmony. Their stars barely shift. Their cores hold steady. Their memory remains intact. If the galaxy is a body, then these halo clusters are its quiet thoughts, suspended in the dark, beyond conscious motion. From Earth, they are hard to see, but with the right lens, they flicker into view like sparks resting on the edge of forever. In their silence, there is no fear, only the calm of age, the grace of endurance, the quiet testimony of stars that chose distance over drama and still shine. Some clusters remember the beginning. Their stars formed before the galaxy, settled into spirals. These clusters are not merely old, they are relics, time folded into light. Each one is a fossil, not of bones or shells, but of starlight born when the universe itself was young. When you gaze into these clusters, you are seeing stars that have lived for more than 12 billion years, long before planets formed, before galaxies grew their arms. These stars were already burning. Their chemistry is different, simpler. They carry fewer metals, a sign that they were made before many stars had died, before the cosmic ingredients had mixed and enriched the universe. Their orbits are wide, their paths slow. They drift like memories around the galaxy, quiet and unchanged. In them, astronomers read the early chapters of cosmic history. Through their light, we learn about the first conditions of matter, the nature of primordial gas, the gravitational tugs that shaped our galaxy's birth. They are the grandparents of the stars, and in their steady glow, they tell stories of a time we cannot touch, only witness. Like amber holding an ancient insect, these clusters preserve the moment of their making, not in stasis, but in quiet survival. They still shine, they still move, they still hold each other close, and we, drifting far below in the spiral arms, can only look up in wonder. These fossils are not buried. They hover above us, still alive, still turning, echoes of the beginning, carried gently through the dark. Older stars carry less metal. They shine with a purer, more ancient light. In the earliest days of the universe, metals were rare. The first stars were forged from hydrogen and helium, the simplest elements, born moments after the Big Bang. Heavier elements like iron, carbon, and oxygen had not yet spread across the cosmos. They had to be built slowly inside the hearts of stars and scattered through time by supernovae. That is why ancient stars in old clusters shine differently. Their light is cleaner, almost untouched. Astronomers call this metallicity, a quiet measure of what these stars contain. And with this measure, we can read their age. The less metal, the older the star. These low metallicity stars are like time travelers. They whisper of an era before planets, before life, before dust carried complexity across the void. In the centers of globular clusters, these old stars gather tightly, their glow unwavering, their chemistry unchanged. Their light is faintly yellow, their hearts slow burning, their presence patient. When we analyze their spectra, the rainbow signature of their starlight, we find a fingerprint of the early universe. No noise, no clutter, just the elemental simplicity of what once was. And in that simplicity, there is elegance. These stars are survivors from a time when the universe was still new, still learning how to shine. They remain untouched by the billions of years that followed. Like fossils glowing instead of crumbling, they carry the story of cosmic youth, still alive, still alight, still holding the first breath of stardust. Plotting a cluster's stars reveals a soft curve, a fingerprint of shared origin, written in brightness and hue. Each cluster carries a signature, not in writing, but in light. Astronomers trace this signature with something called a color magnitude diagram, a chart that maps a star's brightness against its color. On this plot, stars in a cluster do not scatter randomly. Instead, they fall into place, like notes on a staff, forming a gentle curve that sings of their shared birth and age. The brightest, bluest stars sit high, and to the left, often the youngest and most massive, burning hot and fast. The redder, older stars drift lower and to the right, slower, cooler, nearing the end of their luminous journey. This shape, this arc, tells a story of time passing inside the cluster. It shows how stars evolve in concert, how their light shifts with age, and how their family tree bends towards silence. In some clusters, the arc breaks gently, signaling that some stars have already moved into giant phases. In others, the curve is smooth, still young. But always, it holds meaning. Just as tree rings reveal the seasons of growth, this diagram reveals the quiet seasons of stars. It's not a loud display, just a whisper of color and brightness, speaking in the soft grammar of physics. And yet, within this diagram is everything. A portrait of a family of stars, aging together, glowing side by side across vast distances, a constellation of data transformed into poetry, a celestial fingerprint held softly in light. Blue stars should be gone, yet some clusters still cradle them like embers burning backwards. These stars, called blue stragglers, are a cosmic riddle. In ancient clusters where all the massive blue stars should have burned out billions of years ago, a few still glow with that unmistakable, youthful heat. They are brighter and bluer than the rest, standing out like flickers of fresh fire in a room full of embers. But how? In a family of old stars, how do a few stay young? One theory whispers of stellar mergers, two aging stars drawn close in the crowded cluster core, their boundaries blurring, their lives restarting. Another suggests mass transfer between binary partners, one star feeding the other, giving it fuel to shine again in blue. However it happens, the result is strange beauty. These blue stragglers defy time. They glow like memories, refusing to fade, like a spark rekindled just as the fire was dying. Their presence tells us that clusters are not static. Even in stillness, things move, touch, change. These stars are evidence of interaction, of gravitational intimacy, of the delicate dance within dense stellar cities. They are rare and they are quiet, but their color speaks loudly. Against the backdrop of redder, older light, they gleam with surprise, an anomaly, a question, a gift. In them, the story of the cluster stretches unexpectedly, a reminder that even among the ancient, something new can rise. Even in a place of endings, something can still begin again, blue, bright, and burning softly against time. Red giants swell gently within the cluster, aging suns glowing like coals. In the quiet life of a star, there comes a moment of soft expansion. When hydrogen runs low in the core and the balance of forces shifts, the star begins to swell, not in haste, but in a long, graceful breath. It becomes a red giant, its outer layers cooling and expanding, its heart contracting with steady intensity. Within clusters, these red giants are easy to spot. They burn with a steady amber glow, warmer and wider than their neighbors. Their light is not as sharp as the blue of youth, but it is deeper, more contemplative, the ember after the flame. Each red giant is a future remembered in advance. Our own sun, too, will one day walk this path. In a few billion years, it will stretch out like this, vast, red, and slow. Red giants and clusters mark the turning of a stellar page. They represent not decay, but transformation. Inside, helium fuses. The core burns brighter, even as the edges cool. They live in this phase for a long while, their radiance unfurling gently into the night. Among the cluster's crowd, they offer a quiet contrast, not loud, not fast, but steady. A reminder that brightness isn't always about intensity. Sometimes it's about endurance. These stars don't rush to the end. They soften into it. In their crimson light, we see the calm of aging, the dignity of change, and the warmth that lingers long after the first fire has passed. Among the elders, a few stars seem too young. These are blue stragglers, strange, luminous, out of time. They are the odd ones out, in ancient globular clusters where all massive blue stars should have long faded. A few still burn bright, still pulse with the energy of youth. It's as though they've missed the passage of billions of years, suspended in a brilliance that should no longer be. Blue stragglers are not newborns, yet they shine like them. They are the mysterious exceptions in an otherwise predictable pattern. Most stars in a cluster follow an orderly path, forming together, aging together, dimming together, but these defy that flow. They shimmer defiantly near the top of color magnitude diagrams where only young hot stars should be. What makes them glow again? Perhaps two aging stars collided gently, merging into a single, rejuvenated body. Or perhaps one star siphoned mass from a quiet companion, reigniting itself in the process. Whatever the cause, they are quiet miracles of timing and closeness, stellar second chances. In a cluster full of ancient warmth, they sparkle like echoes of beginnings. They remind us that time is not always a straight line, that even in old places, something new can flicker into being. Their presence is rare but meaningful, a gentle disruption of what we thought we understood. In their blue light is the whisper of possibility, that even when the crowd has grown old, even when the night seems full of endings, a few stars might still learn how to burn again, brighter, younger, against the current of time. Clusters are like laboratories suspended in space, each star an experiment in time. Unlike random stars scattered across the sky, clusters offer clarity. All their stars were born together from the same cloud at the same moment in cosmic history. What changes then is not when they started, but how they've aged. In this uniformity lies their gift to science. By comparing stars of different masses within a single cluster, astronomers can watch the entire life cycle of a star play out in one celestial snapshot. The most massive stars burn fast and fade early. The smaller ones linger, shining quietly for billions of years. This spread allows us to map the journey from main sequence to red giant, from fusion to collapse. In young open clusters, we see stars just beginning their lives, spinning fast, wrapped in dust. In ancient globular clusters, we see the slow glow of red giants, the delicate presence of white dwarfs, and the occasional straggler burning out of sequence. These stellar families show us what changes and what remains. They teach us how stars live and die, how they affect one another, how even gravity cannot stop the soft unraveling of time. A cluster holds 1,000 lessons, each star a chapter, each brightness a sentence, each hue a clue. Together, they form a book, not of fiction, but of quiet truth written in light. To study clusters is to study the very architecture of time itself. Not in haste, but in patient observation, the cosmos slowly reveals how stars become stories. Some clusters fade quickly, dissolved by time, by tides, by motion. Not every stellar gathering lasts. Some clusters are born already fragile, loosely bound, scattered across the galactic sky. Their beginnings are bright, new stars flaring to life in a chorus of radiance, but their endings come gently, gradually. Gravity, though strong, can only do so much against the tides of the galaxy. As the cluster orbits through the Milky Way, it feels the tug of other stars, the pull of galactic arms, the nudges of passing clouds. Each pull takes a little more cohesion. A few stars peel away, a few more follow. What began as a cradle of siblings becomes a widening diaspora. Open clusters are the most vulnerable. Their stars are lightly held, their lifespans short in cosmic terms. Within a few 100 million years, many dissolve entirely. What remains is not silence, but a soft scattering. Stars moving in parallel, their bond no longer visible, but still subtly shared. These clusters don't die with drama. They simply blur, fade into the backdrop of the galaxy. They leave behind no remnants, only motion. Yet their dissolution is not failure. It is part of the cycle. Just as clouds collapse into stars, so do clusters relax into the wider sky. Even in their unmaking, there is beauty, a quiet diffusion, a graceful letting go. And in the wide arms of the galaxy, those scattered stars continue to shine, alone now, but still echoing the memory of where they began, together in a single breath of light. Even when the cluster is gone, its memory lingers, a stream of stars still moving together. These are stellar streams, faint ribbons of light tracing paths across the galactic sky. Though the cluster has unraveled, though its center has melted away into the dust of time, its children remember the way. Gravity may no longer hold them tightly, but momentum keeps them aligned. They drift softly, but in chorus. Each star, a solitary light, still carries the signature of its birthplace. Same chemistry, same direction, same quiet rhythm. To the naked eye, they look like scattered points, but with patient observation and careful mapping, astronomers see the pattern, a long, slow arc of siblings in flight. These streams are time's handwriting. They trace the galaxy's history, where clusters once were, how the Milky Way pulls and shapes, how orbits bend across eons. They also help us understand dark matter, that invisible web that cradles the galaxy. For as these streams stretch and sway, they feel the contours of the unseen. Each shift, each kink in the ribbon reveals something of the mass that hides in shadow. A dissolved cluster is not gone. It is simply transformed, no longer a point of light, but a thread, a whisper, a memory made visible. And in that drift, there is no loneliness, only the soft continuation of a journey begun together. The stars no longer embrace, but they still echo, moving in synchrony, remembering the shape of their beginning. Like leaves on the same wind, they carry the story forward, quiet, scattered, and still connected by origin. Not all stars stay. Some drift too far, pulled gently from the edge. The boundaries of a star cluster are not walls. They are soft, shifting thresholds, a delicate line where gravity's grip begins to loosen. Within, the stars orbit in a shared rhythm. But at the edges, some begin to dance differently. A slight nudge from a passing star, a tiny tug from the galactic tide. These are enough to change a path, to set a star on a slow departure. It doesn't happen all at once. It happens subtly, over thousands, millions of years. The star, still glowing, still moving, begins to fall away from its stellar family. It carries no resentment, no farewell, only motion, only distance. These wanderers are called escapers, stars that no longer belong to the gravitational web of their cluster. Some leave behind faint trails, marking their journey like footprints in starlight. Others blend into the galactic field, indistinguishable from those born elsewhere. But within their light is a fingerprint, a match to the ones they left behind. Astronomers tracing spectra and paths can find them, reunite them in story, if not in space. A star that has wandered is not lost. It is simply further along its own arc, and even in solitude, it remembers. In its atoms, in its motion, in the gentle direction of its drift. Not all departures are lonely. Some are simply inevitable, a quiet step outward, a soft release. Even the stars know when it is time to go, and how to carry their origin with grace. With just enough speed, a star can slip free, released into the wider galaxy, no longer bound. This is escape velocity, the point where gravity's fingers can no longer hold. A star, once part of a collective, builds momentum, sometimes through gentle accumulation, sometimes through encounter, a close brush with another star, a gravitational slingshot, a push from the tides of the galaxy. It gains speed not to flee, but to drift, outward, onward, unanchored. The cluster does not resist. It lets go without resistance. This is not a rupture, but a release, a graceful separation. The star departs, not in haste, but in slow acceleration. And as it moves into the wider galaxy, it joins a new rhythm. The arms of the Milky Way swirl open before it. New paths, new alignments, new silences, yet something of the cluster remains. Its chemical makeup, its memory of motion, a trace of togetherness hidden in its elements. Escape is not a betrayal of origin. It is part of the pattern. Not every star was meant to stay forever. Some were always destined to roam, and as they glide outward, they become messengers, silent carriers of their cluster's story, alone, but not without history. In their solitude is expansion, in their motion, freedom. The galaxy does not hold tightly. It allows for flight, for scattering, for the poetry of release. And so the star goes, slowly falling away from the only home it has known, not to forget, but to stretch the memory further across the sky. Pairs of stars circle one another. In the dense core, these dances grow more complex. In the heart of a cluster, where stars are packed like glowing grains of sand, binaries spin in quiet partnership. Two stars bound by gravity, orbiting a shared center, caught in a delicate gravitational ballet. Their orbits can be wide and slow, or tight and swift, depending on their masses, their histories, their invisible push and pull. Some have orbited together since birth, born from the same swirl of gas and dust. Others find each other later, captured in the gravitational churn of the cluster's dense interior. These pairs are more than companions. They are stabilizers. Their presence affects the motion of nearby stars, the temperature of the cluster's core, the pace of its evolution. Sometimes their closeness leads to drama, one star spilling matter onto the other, igniting brilliant flares or subtle X-ray whispers. Other times they merge, becoming a single, brighter sun. In such tight quarters, these unions and separations are common. The core is restless, not with speed, but with density. Every motion has consequence, and amid that crowded quiet, binaries endure, two lights moving as one, each a counterweight to the other's pull. Their dance is unhurried but constant, a rhythm that marks time in centuries, millennia, epochs. In the vastness of the cluster, they are a reminder. Connection persists. Not all stars drift alone. Some stay close, holding gravity's hand, circling forever through the quiet hum of creation's oldest music. Some clusters hide something darker, a quiet mass, unseen, perhaps a black hole at the center. Not all centers are filled with light. In some globular clusters, stars swirl around an emptiness that reveals itself only through motion. They move faster near the heart, drawn inward by something massive and invisible, a clue, a whisper, a gravitational ghost. Astronomers watch these signs closely, suspecting that within some clusters lies a black hole, not like the giants at galactic centers, but smaller, subtler, quieter, intermediate mass black holes, still mysterious, possibly born from the merging of massive stars long ago. These black holes do not roar. They do not devour entire systems with spectacle. They hum with mass, gently pulling the cluster's heart tighter, denser, more compact. Occasionally, a nearby star drifts too close. It may spiral inward, brighten with heat, and then vanish. But mostly, the black hole waits. Its presence is known not by light, but by the behavior of others. Stars that speed up, curve their paths, dance around an invisible core. In these moments, the cluster becomes a map of unseen forces, a choreography of light around shadow. We cannot see the black hole itself, but we read its influence like a fingerprint pressed into starlight. It reminds us that in the calmest places, something powerful may rest, that darkness is not always empty, and that even in a place filled with stars, the deepest secret may be the quiet presence of something that does not shine, yet holds everything near it with perfect, silent certainty. New clusters are born even now. In dusty nebulae, stars still awaken in groups. The universe is old, but it hasn't stopped creating. In vast clouds of gas and dust, tucked away in quiet corners of galaxies, gravity is still at work. Slowly, patiently, it gathers the scattered elements of creation. These nebulae are not empty. They are waiting. Within their folds, pressure builds, temperatures shift, and stars begin to form, not one at a time, but in flocks, the same way they always have. Clusters rise from these cradles, loose and glowing, like embers kindling in the mist. These newborn clusters shine brightest in infrared, still cloaked in the dust that made them. Their stars are hot, young, sometimes massive. The gas around them dances with heat and light. In time, the radiation from the stars pushes the dust away. The cluster emerges revealed. Some will stay together for millions of years. Others will dissolve before they fully take shape. But for a moment, they exist, together, luminous, new. We often think of the universe as something finished, or static, or ancient, but in truth, it is always beginning again. Every hour, somewhere in the cosmos, a star awakens beside a sibling. A new cluster breathes its first collective light. In distant galaxies, in nearby arms, the rhythm continues. Birth, light, expansion, dispersal. The story of clusters is not just history. It is ongoing. Creation is not done. The sky is still gathering. And tonight, beyond our view, another cluster may just be forming. In galaxies ablaze with birth, clusters ignite quickly, tucked inside clouds glowing in infrared. Starburst regions are galaxies caught in the act of transformation. Whole swaths of space erupt with light, as if the universe itself is breathing in and out through stellar lungs. In these fevered zones, stars are born at a furious pace, dozens, hundreds, thousands at a time, and not in isolation. These stars rise together, clustered within their mother clouds. Embedded clusters, still hidden in their dusty cocoons, burn bright in wavelengths our eyes cannot see. Infrared telescopes reveal them, warm knots of light emerging from the smoke of creation. The dust does not simply obscure, it shelters. It holds the newborn stars like hands around a flame. These regions are both chaotic and calm. The chaos of heat, radiation, collapse. The calm of stars forming side by side, bound for a shared path. Some of these clusters will break free from the cloud as the radiation clears the dust. Others will remain swaddled longer, hidden and safe. Starburst galaxies like M82 flicker with these births, whole generations forming in a single cosmic breath. The embedded clusters tell us, birth is not always loud. Sometimes it's hidden. Sometimes it happens in warmth and silence. These young clusters do not yet know their fate, whether they'll stay intact or scatter into the galaxy's arms. But in this early moment, they shine with unity, a burst of new light in a galaxy's dark. The cosmos, always older, still finds ways to begin again. Nebulae collapse in silence, and in that quiet, clusters begin. A nebula is not empty space. It is the breath of stars lingering. These great clouds of gas and dust stretch across light years, delicate yet massive, painted in silvers, pinks, and purples, where light can find a way through. But within, hidden from visible sight, something ancient stirs. Gravity whispers through the cloud, gathering material into denser knots. It does not shout. It waits, patient, drawing hydrogen toward hydrogen until the weight becomes heat and the heat becomes light. Stars are born, and rarely are they born alone. A single nebula may yield a cluster, tens, hundreds, sometimes thousands of stars, all igniting in slow unison. Their light begins as a murmur filtered through veils of dust. Over time, it strengthens. Radiation from the youngest, hottest stars pushes the surrounding dust away, revealing a soft constellation where none was seen before. These clusters do not yet know how long they'll last. Some will hold together for millions of years. Others will drift apart before they're even named. But in that early moment, they exist in a kind of harmony, a shared origin, a glowing cradle. We see these births scattered throughout our own galaxy, in Orion's sword, in the Eagle Nebula, in the silent folds of the Carina. Each cluster is a phrase in the long song of cosmic creation, and it all begins inside a cloud, with silence folding in on itself and starlight blooming in the dark. Just beyond the sword of Orion lies a hidden cradle, a newborn cluster, still swaddled in dust. The Orion Nebula is one of the few stellar nurseries visible to the naked eye. From Earth, it appears as a faint blur below the belt of Orion, but through a telescope, it becomes a world of motion and mist. This is where stars are still being born, not in theory, but in real time. Inside the nebula, a young cluster pulses with energy. The trapezium, a group of massive, radiant stars at its core, illuminates the surrounding cloud, sculpting gas into pillars, waves, and arcs. Dust swirls like a veil around them, filtering their light into soft glows. This is not a still scene. Winds blow, radiation flows, new stars blink into being within the folds. Some are already surrounded by protoplanetary disks, hints of future solar systems taking shape. And yet, for all its activity, the nursery is calm, not in silence, but in scale. These processes stretch across thousands of years, a lullaby measured in millennia. The cluster forming here may not last. The brightest stars will age quickly, pushing others away with their strength, but for a moment they remain together, born of the same breath, lighting the same cradle. We watch from afar, from across a light years and centuries, catching only a glimpse of this stellar childhood. The Orion Nebula is not just a place on the map. It is a beginning, unfolding slowly, softly, one glowing sibling at a time. Dust softens light, but also protects. It cools, it shields, it cradles. In the birthplace of stars, dust is not just debris, it is sanctuary. Tiny grains of carbon and silicate formed in the hearts of dying stars drift through the galaxy until they find themselves pulled into a growing nebula. Here, in the deep, cool folds of the cloud, they gather. Dust doesn't shine, it absorbs, it conceals, but in that very act, it allows something new to emerge. It blocks harsh radiation from outside. It slows the collapse just enough for gravity to take shape without chaos. It cools the cloud, allowing it to contract, to fold inwards, to become the seedbed of stars. In these dusty wombs, clusters form quietly. Their first light struggles to escape, caught and scattered by the veil. Observed from afar, these embedded clusters appear only in longer wavelengths, infrared images revealing warm knots of becoming. Dust gives time for stars to form in proximity, time for disks to spin and planets to gather. And even after the stars ignite, the dust lingers, sculpted by stellar winds into pillars, arches, and waves. Eventually, the pressure from radiation will blow it away, revealing the new cluster, like dawn lifting fog. But the dust was never passive. It was the artist behind the scene. Without it, there would be no stars, no clusters, no galaxies filled with light, just the cold emptiness of hydrogen alone. In the darkness, dust holds the first whisper of light. Invisible fields thread through the cloud, guiding gas, shaping stars, holding the chaos still. Though we cannot see them, magnetic fields are present in the wombs of stars. These unseen lines of force stretch through the collapsing clouds like threads in a tapestry, guiding the motion of particles too small to sense on their own. Without them, the cloud might collapse too quickly or fragment too wildly, but magnetism slows the fall, offers structure to the chaos, and shapes the formation of clusters from within. The gas, charged and responsive, follows these fields like iron filings around a hidden current. As gravity pulls inward, the magnetic lines twist and stretch, adding tension to the fabric of the nebula. In the densest regions, these lines converge, and within their quiet scaffolding, stars begin to take form. The early stages of a cluster are not just about mass and light. They are about balance, resistance, and invisible choreography. Infant stars often rotate, and magnetic fields link that spin to the surrounding cloud, siphoning excess energy and letting the newborn star settle. These same fields may help launch stellar winds or shape the disks where planets begin to gather. We imagine starbirth as fire and collapse, but it is also restraint. It is the gentle pull of forces unseen, slowing, guiding, allowing. Clusters owe their grace not only to gravity, but to these delicate, invisible filaments. They are the quiet threads that hold the cradle together, unseen, unspoken, but essential to the shape of every glowing group of stars. Clusters shed their veils. As stars ignite, the gas is pushed away. In the early life of a cluster, the stars are born wrapped in layers of gas and dust, like infants swaddled in light. This gas is not idle. It flows, it ripples, it shimmers with the quiet breath of creation. But as the stars awaken, they begin to change their environment. Radiation pours from the most massive among them, ultraviolet light strong enough to ionize the surrounding hydrogen. Winds begin to blow, not like the breezes of Earth, but great rivers of charged particles rushing outward from stellar surfaces. These forces press into the gas, heating it, pushing it back, sculpting it into glowing arcs and hollowed cavities. What was once a cradle becomes a shell. Slowly, over thousands of years, the gas disperses. The cocoon that kept the young cluster hidden is lifted, and the newborn stars emerge into view. Some will remain bound by gravity, staying together as an open cluster. Others, more loosely held, may drift apart as the gas that once added mass and cohesion is lost. The shedding of gas marks a turning point. The cluster is no longer forming, it is becoming. Exposed now to the broader forces of the galaxy, its future will depend on its own gravity, its density, and its resilience. Yet even in this dispersal, there is beauty. The light of these young stars reflects off the departing gas, painting the sky with pinks and blues, a farewell, soft and glowing, to the place where stars first learned to shine. Sometimes gravity isn't enough. The cloud disperses before the stars can hold. Not every gathering of stars becomes a cluster. Some begin with promise, a cloud rich in gas, cold enough to collapse, quiet enough to cradle new stars, and yet something intervenes. A nearby supernova may roar to life, sending shock waves that rattle the cloud and tear it apart. Or perhaps the first stars to ignite are too massive, their radiation too intense, blowing away the surrounding gas before the rest can follow. Without enough mass, without enough time, the cloud disperses. The stars that had begun to form fall away from each other, never achieving the cohesion needed to remain a group. They are siblings in name only, scattered before they could know the bond. These unfulfilled clusters leave behind something different, loose associations, moving groups, or nothing at all. We may never know how many nearly formed clusters were lost to haste or disruption, but the galaxy carries their traces, young stars moving in similar directions, their motions hinting at a common past. There is a melancholy in this failure to coalesce, but also a quiet truth. Not all beginnings must reach completion to have meaning. Some stars go on to shine brightly alone, or find themselves folded into new formations. The story of clusters includes these near misses, moments where the balance wasn't quite right, where the cradle was rocked too soon. In the great tapestry of the cosmos, even the undone threads contribute to the whole. Even the almost clusters have their place in the quiet sky. Far from the disk, globular clusters circle like moons. They move slowly, steadily, untouched by the galaxy's arms. High above the spiraled whirl of stars and dust, there is a stillness, not silence exactly, but a different kind of motion, slow, deliberate, aged. Here in the galactic halo, globular clusters drift like old lanterns swinging in wide, looping arcs. They do not travel within the crowded plane of the galaxy, where stars buzz and nebulae bloom. Instead, they orbit in the vast outskirts, far from the crowded arms, like memories circling the mind's edge. Their orbits are not fast. It may take hundreds of millions of years for a single pass around the galactic core, but in their motion, there is stability. Each cluster is a tightly bound system, its stars pressed close by ancient gravity, its path held steady by mass and patience. From Earth, We see them as dense, round smudges in the sky, but through telescope eyes, they erupt into a field of stars, sparkling like dew across a globe. These clusters are not part of the daily bustle of starbirth and dust storms. They are relics of the galaxy's earliest days, wandering through the halo like elders with long memories. They trace orbits untouched by the spiral arm's rotation, their trajectories sometimes tilted, sometimes retrograde. Their presence tells us that the galaxy is more than its disk. It is surrounded by an unseen sphere of time-worn brilliance, and in that halo, the globular clusters keep their quiet, ancient watch. A few globulars are older than our home. They began before the Milky Way had shape, before the spiral arms, before the bar of stars at the center, before the galactic disk flattened into its familiar swirl. Some clusters were already there. These ancient globulars were born in the early universe, nearly 13 billion years ago, when hydrogen clouds first collapsed into stars. They may have formed in the fragments of galaxies that later merged, or in the primordial turbulence that seeded structure into the cosmos. Whatever their origin, they existed before the Milky Way as we know it. The stars within them are old beyond comprehension, low in metals, high in endurance, shining with the light of a younger universe. To look at these clusters is to peer backward through cosmic time. Their survival is remarkable. Through mergers, collisions, gravitational tides, and eons of slow erosion, they have endured. They are the fossils of a time before shape, before stability, before this galaxy gathered itself into a spiral. It's possible that some were captured, pulled in from smaller galaxies long ago. Others may have formed in situ within the deep halo's earliest waves of star formation. In either case, they now move with the Milky Way, orbiting like quiet witnesses. Each one carries the story of a time when the universe was only beginning to understand how to form light and structure. They are not just old, they are ancient beyond memory. To observe them is to touch something that predates the very home in which we float. Their paths are not random. Each orbit a story, a trace of galactic history. Globular clusters do not move blindly. They follow wide, deliberate arcs around the galaxy, their trajectories shaped by forces stretching back billions of years. Their motions act like footprints pressed into space-time. And by tracking these paths, astronomers read the galaxy's past. Some clusters move with the rotation of the Milky Way, as if born in harmony with its spin. Others move against the flow, retrograde travelers hinting at foreign origins. These backward paths whisper of mergers, of smaller galaxies long ago pulled in, disrupted, and absorbed. Their clusters remained, like relics tucked into orbit, still tracing the memory of where they came from. The speed, tilt, and shape of each cluster's orbit tells of mass distributions, past collisions, and unseen forces. Even the dark matter that cradles the galaxy leaves fingerprints in how these clusters drift. By studying their movement, scientists map what cannot be seen, the gravitational landscape that holds the Milky Way together. Clusters that dive close to the center show us the strength of the core. Those that soar out far reveal the galaxy's reach. Some paths wobble slightly, perturbed by tidal interactions. Others have smooth, stable loops, like the strokes of a pen across deep time. Each motion, no matter how slow, carries a quiet echo of the universe's choreography. And in their rhythm, we hear the galaxy's memory, not in words or light, but in the graceful curves of stars bound and drifting together through the vastness. Some dive steeply, others glide in long, lazy loops. The orbits of star clusters are not uniform. Like dancers choosing different steps, they each trace a unique pattern through the galaxy. Some plunge steeply through the galactic plane, slicing down from the halo like arrows falling from high above. Their paths are sharp, elliptical, and elongated. They speed close to the center, then swing far out again into the quiet. These plunging clusters carry energy, their trajectories shaped by gravitational encounters and long-forgotten galactic collisions. Others, more reserved, drift in smooth circles or gentle ellipses, moving slowly around the Milky Way's heart like leaves caught in a calm eddy. Their orbits are wide and lazy, stretched over millions of years. Some remain mostly in the halo, rarely dipping near the disk. Others skim just above it, passing quietly through the galactic suburbs. There are even clusters whose paths are tilted, inclined at odd angles, signs that they may have come from another galaxy entirely. The diversity of these motions reveals the galaxy's complexity. It is not a flat, simple system, but a layered, dynamic space with many moving parts. Each path is like a thread in a celestial tapestry, some tight, some sweeping, some unraveling slowly. When visualized together, the orbits form a halo of movement, not chaotic, but intricate, a choreography written in gravitation. And even though these clusters drift for billions of years, their paths remain legible, a stellar script written across the galaxy, recording the shape of space and the history of motion itself. A few move the wrong way, backwards across the galactic tide. Among the many star clusters that circle our galaxy, a rare few defy the flow, while most follow the Milky Way's spin, orbiting in the same direction as its stars and gas. Some clusters drift in reverse. They move retrograde, sliding backward across the grand spiral's tide. This isn't an error, it's a clue. These backward travelers did not begin here. They are likely visitors, born in smaller galaxies that wandered too close, then fell inward, merging with the Milky Way over billions of years. As those galaxies were pulled apart by tidal forces, their star clusters survived, set adrift, still moving in the direction they were born. Retrograde clusters are celestial fingerprints left by long-vanished systems. Their presence confirms what the galaxy rarely shows on its surface, that it is built from mergers, from cosmic cannibalism, from the slow gathering of smaller things into something vast. When astronomers trace the paths of these backward drifting clusters, they often find shared origins, similar orbits, similar compositions, as though they are the scattered jewels of a once whole crown. These relics preserve their history not in stone, but in motion. Their orbits carry the memory of an ancient direction. And though the Milky Way continues to spin forward, these clusters offer a quiet counterpoint, proof that not everything must follow the current to belong. They orbit still, slow and steady, like old thoughts returning in reverse, adding depth to the galaxy's story with every silent loop. They are not just old, they are records, each one a preserved whisper of the early universe. To look at a star cluster is to read a page from a book the universe began long before us. These are not just gatherings of stars, they are fossils frozen in motion and light. Each one preserves the conditions of its birth, the chemistry of its gas, the age of its stars, the shape of its orbit. Together, they form an archive older than any planet, any moon, any mountain. Clusters tell us about the environments in which they formed. A globular cluster with stars low in metal, speaks of a time before heavy elements had spread, when the universe was still new and its stars forged only hydrogen and helium. Others, with more metallic hues, formed later as generations of stars seeded the cosmos with new material. Their arrangement, density, and color give clues to astronomers about the pace and shape of galactic evolution. Clusters are durable, outlasting the nebulae they came from, the galaxies that once housed them, even sometimes the structure of the galaxy they now orbit. Their survival is a form of storytelling. They resist disruption, carrying the ancient blueprint of star formation from ages past. As they orbit, they trace invisible paths that cut through time. Their existence says, "This is how things once were." They are fossils not of stone, but of starlight, quiet remnants of creation, still glowing. In every cluster, a whisper remains, reminding us that the galaxy we see today was built upon countless moments now long gone. Some clusters came from elsewhere, carried in by ancient mergers. The Milky Way was not always whole. It has grown slowly across eons by absorbing others, smaller galaxies drawn close by gravity, then stretched, scattered, and swallowed. Yet not everything is lost in these encounters. Star clusters often survive, tucked within the incoming galaxy, like pearls in a drifting shell. When the merger ends, those clusters remain, now part of a new home, but carrying the rhythm of the one they left behind. Their orbits often don't align. Their chemistry may differ. Their paths may be tilted, eccentric, or retrograde, subtle traces of the place they were born. Astronomers call these signatures merger debris, but that name belies their beauty. These clusters are time capsules, carried intact through disruption, still whispering the names of galaxies long erased. Some trails of clusters can even be linked together, outlining the skeleton of a devoured galaxy, like crumbs, marking the passage of something now gone. The sky holds many such fossils. With every new map, more are found, clusters that do not match the Milky Way's tempo, like guests who arrived through storms. They orbit now in silence, but their very existence changes how we understand our galaxy. We did not begin here alone. The Milky Way is not a singular entity, but a mosaic, and the clusters from past collisions are the tesserae that make its history visible. Quietly, they drift, not as ruins, but as survivors, still circling, still glowing, still telling us how galaxies grow by touching, by tearing, and by becoming something more, captured, torn free, and left behind. Stripped clusters now drift in our halo. Imagine a small galaxy approaching the Milky Way, a faint, flickering companion, orbiting too close for too long. The tidal pull of our larger galaxy stretches it, shakes it, breaks it. Stars fly loose, gas is pulled thin, and in the quiet heart of that dwarf galaxy, star clusters, dense, luminous, stubborn, are among the last to remain whole. But even they cannot resist forever. Gravity unfastens them one by one, and the clusters are left behind, abandoned but not lost. Now they orbit the Milky Way, detached from their original home, like seeds carried by wind across intergalactic space. These are the stripped clusters, remnants of smaller systems consumed by larger ones. Some of them still remember where they came from, their motions grouped, their compositions aligned. Others have drifted long enough to blend in, nearly indistinguishable from native clusters, but traces remain. Their unusual paths, their distinctive chemistry, their groupings with faint streams of stars from the same vanished source. They are echoes of galaxies now erased, held together in glowing fragments. And while the galaxies they came from may no longer exist, their clusters continue. They become part of something bigger, orbiting a new center, telling a new story. This is how the Milky Way grows, by absorbing not just stars and dust, but entire histories. These clusters are survivors of quiet cosmic theft. Drifting now in our galactic halo, they carry the memory of distant beginnings and the resilience to keep shining through change. When clusters die, they leave trails, ribbons of stars stretched across the sky. A star cluster does not vanish all at once. It unravels slowly, gently, across time. Gravity weakens, bonds loosen, and stars begin to slip away, not in chaos, but in calm procession. These departing stars do not scatter at random. They leave in streams, long and thin, tracing the path the cluster once followed. Like a wake behind a boat, these stellar streams remain long after the cluster at their center has dissolved. They stretch across the sky, faint and barely visible, but real. Astronomers detect them as subtle overdensities in starlight, elongated arcs winding through the halo of the galaxy. Each stream is a memory, flowing outward, preserving the direction, the momentum, the shape of what was once whole. These streams tell stories of loss, but also of connection. Many were born from clusters pulled apart by the Milky Way's tides, scattered by its gravitational embrace. Others may come from dwarf galaxies or globulars stripped over billions of years, but none are random. They are aligned, consistent, echoing the order that once held them tight. They become tools for astronomers too. By studying their shapes and motion, we can map the unseen gravity of the galaxy, even the dark matter that holds it all together. And so, even in dissolution, clusters contribute. Even in their fading, they trace beauty. Long after the last star drifts free, their quiet arcs remain, not as ruins, but as paths, written in stars, whispered across the galaxy's wide and open sky. One such stream comes from Sagittarius, a galaxy being pulled apart as we speak. The Sagittarius dwarf galaxy is not a distant memory. It is a present event. Even now, it orbits too close to the Milky Way, caught in a slow spiral of surrender. With each pass around our galaxy, it loses more of itself. Stars are pulled loose, drawn into long tidal streams that wrap around the Milky Way like silver threads. Among these stars are clusters, once nestled in the heart of Sagittarius, now drifting alone. This is not destruction in the violent sense. It is more like unraveling. Gravity tugs gently, persistently, until what was once a galaxy becomes a lacework of memory across the sky. The Sagittarius stream is one of the clearest examples of galactic merging in progress. It's visible in both hemispheres, cutting across constellations like a river of light. Star clusters from Sagittarius still move with its rhythm. Some have been catalogued, like M54, now residing deep in the Milky Way's halo, but still humming with the chemical voice of its home. These clusters remind us that galactic growth is ongoing. The Milky Way is still becoming, still gathering, still reshaping what it touches. When we observe the Sagittarius stream, we witness a transfer of history, a smaller galaxy gifting its stars, its clusters, its light to something larger. And in that gift, both are changed. The Milky Way gains mass, memory, complexity. Sagittarius becomes a story written not in one place, but many, its stars now scattered, but still singing together in orbit. The halo is quiet. Within it, clusters drift like forgotten thoughts, circling a sleeping mind. The galactic halo is not where light gathers loudest. It is a place of hush, a sparse, spherical envelope that extends far beyond the spiral arms, far beyond the glowing disk. Out here, stars are few, gas is thinner, time feels slower, and yet, scattered throughout this quiet sphere are clusters, mostly globular, mostly ancient. They do not light up the halo like lanterns, but they dwell in it like embers. Drifting high above the plane of the Milky Way, these clusters are reminders of a different era. They orbit in long ellipses, crossing through the galactic disk only rarely, like messengers from a higher, older order. Some were born here, others were adopted, captured from smaller galaxies long ago, but all of them share a kind of isolation. They are not wrapped in star-forming clouds, not surrounded by noise or heat. They are alone, but not lost. The halo protects them in its stillness, shielding them from the busyness of the galactic center. And they, in turn, help map its shape. Because they are few, and because they orbit far, their paths are like traceries, defining the size and symmetry of the galaxy's extended reach. When astronomers look for the Milky Way's boundaries, they follow these clusters, not because they shine brightest, but because they endure. In the silence of the halo they circle, unbothered, unhurried, ancient and afloat, anchored by gravity, adrift in time, a constellation of memory beyond the crowded skies. Clusters age gracefully. Their light tells time, not in seconds, but in spectral lines and fading blue. A cluster doesn't carry a date stamp, but in its starlight, time leaves a signature. Some stars burn blue, hot, fast, and fleeting. Others glow gold or red, longer lived, slower to dim. By looking at the balance between these hues, astronomers can estimate a cluster's age. It's like reading tree rings, not in wood, but in wavelengths. A young cluster will still sparkle with blue giants. An older one will be redder, quieter, with only long burning stars remaining. And not just color, but brightness tells a tale. As stars age, they shift, growing, swelling, sometimes pulsing in the twilight of their lives. By plotting a cluster's stars on a diagram of brightness versus color, a color magnitude diagram, scientists can trace the arc of evolution. There's a turn-off point where stars have just left the main sequence, just started changing. That point is a cosmic clock hand, and the position of that hand marks the age. Some clusters are as young as a few million years, others stretch back nearly to the dawn of the galaxy, over 12 billion years old. Each one is a different chapter of time, and each one's light, though faint, contains the chronology of its stars. In that light, we find a kind of patience, a slowness that matches the age of rivers, of mountains, of continents. Star clusters remind us that time doesn't only tick forward in seconds. Sometimes it sings in spectra, sometimes it glows in color, sometimes it waits in orbit. 12 billion years, a number too wide to hold, yet some clusters have lived that long. These ancient clusters are not just old. They are among the oldest things you can see with your eyes. Born when the universe was young and still finding its form, these clusters have circled the galaxy through its entire life. Long before the Milky Way had spiral arms, before Earth formed, before even the sun was born, they were already there, shimmering, stable, waiting. Their stars are low in metals, untouched by generations of stellar recycling. They shine with a kind of ancient purity, forged from primordial gas that hadn't yet been enriched by the explosions of supernovae. To look at them is to look into deep time. They have watched galaxies merge, They have passed through the expanding fabric of the cosmos, barely altered, barely aging. Inside them, the pace of change is slow. Stars burn gently, gravity holds softly, and the silence of their interiors is matched only by the silence of the early universe they remember. Some of these clusters, like Messier 92 or NGC 6397, have been dated to more than 12 billion years. Imagine what they have witnessed, not with eyes, but with presence, orbit after orbit, loop after loop, threading through the galaxy like pearls strung along time. They are not ruins, they are not fossils, they are still alive, still glowing, still circling. They do not speak, but their light carries the hush of the beginning, still flickering at the edge of now. In the swirl of the galaxy, they endure, held together by gravity and patience. The galaxy is not a still place. It spins, stirs, pulses with motion. Stars migrate, gas clouds collapse and burst. Tidal forces stretch and tear, yet star clusters, especially the globular kind, persist. They move through this cosmic turbulence with a kind of internal calm. What keeps them whole? It is gravity, yes, but not brute force. It is balance. Every star in the cluster is in motion, orbiting a common center, pulled not only by the whole, but by all its neighbors. It's a constant negotiation, a dance of countless small tugs, each adjusting for the others. This dynamic equilibrium, so delicate, is surprisingly durable. The mass of a globular cluster gives it strength, but its symmetry gives it grace. And though encounters with passing stars, spiral arms, and galactic tides threaten to disrupt them, clusters often absorb these disturbances like a pond absorbing a ripple. Their internal structure is tight enough, and their stars are old enough that chaos cannot easily gain a foothold. Even over billions of years, many remain largely intact. It's as if they've learned how to yield just enough to sway but not shatter. When astronomers simulate clusters, they find that this balance is no accident. It's a consequence of age, mass, and the self-regulating nature of gravitational systems. In a galaxy where change is constant, clusters offer a counterpoint, resilience without rigidity. In their patience, there is wisdom. In their order, a quiet defiance of entropy. They float in halos we cannot see. Dark matter cradles them in silence. Star clusters don't drift through empty space alone. Around them and around our entire galaxy lies an invisible structure, silent and undetectable to the eye. Dark matter does not glow, reflect, or absorb light, yet its presence is known by the way it bends gravity. It's the quiet scaffold of the cosmos, shaping galaxies, cradling stars, and guiding the motion of clusters. Within the Milky Way's dark matter halo, globular clusters float like seeds in a vast unseen ocean. This invisible mass helps keep them tethered, not directly, but through the gravitational web it creates. Without dark matter, the galaxy would spin itself apart. Without it, many clusters might drift away. Some theories suggest that dark matter may pool more densely around ancient clusters, remnants of early structures in the universe. Others believe it surrounds them only as part of the galaxy's larger field. Either way, it influences their orbits, their longevity, their very place in the cosmic dance. And yet, we cannot touch it, we cannot see it. We know it only by the pull it exerts, the subtle ways it keeps light in place. In this way, dark matter is like sleep itself, unmeasurable by sight, but essential to the structure it holds. Star clusters floating through the halo are passengers in its gravity, like leaves in a stream of the unseen, carried gently curving silently, wrapped in something vaster than even light can tell. They seem fragile, but their balance is precise. Like dew clinging to a web, a star cluster appears delicate, a gathering of countless stars drifting through the galaxy with nothing visible holding them in place, and yet they do not scatter, not quickly, not entirely. Their cohesion is not the result of any binding force like glue or string. It is a harmony of motion. Each star is in orbit, not just around a single center, but influenced by the gravity of every other star. These orbits create a dynamic, living equilibrium. When one star strays too far, the collective pull nudges it back, or allows it to drift only when the cluster can afford to let go. Especially in globular clusters, where stars are tightly packed, this balance is remarkably strong. Millions of stars can be held in a spherical dance for billions of years. Their structure is not rigid, but it is durable. Like a murmuration of starlings, the cluster's strength comes from the sum of its motions, each part adjusting, yielding, holding. The galaxy's forces try to stretch them, but the clusters respond by bending, not breaking. In open clusters, this balance is more fragile. Their stars do eventually part ways, but even there, for a time, they hold. What keeps a cluster from falling apart is not resistance, but rhythm, not stubbornness, but grace. They are like lullabies in orbit, shaped by harmony, maintained by patience, glowing in the dark like thoughts that never rush away. In the heart of a globular cluster, stars press close, light on top of light, motion on top of motion. There is a hush in the center, but it is not empty. It is a hush made of countless suns, all crowded together like candles in a lantern. In the dense cores of globular clusters, the space between stars can be less than 1/10 of a light year, a cosmic whisper. From Earth, this seems impossible. We look up and see stars as isolated sparks scattered thinly across the sky. But within these clusters, the night would never be dark. Stand in their center, if one could, and 100 suns might rise around you, bathing the void in overlapping glow. Their light mingles, their gravity interweaves. Interactions are more frequent here. Stars pass near one another, exchanging energy, subtly redirecting each other's paths. Some stars may even collide or merge, forming unusual creations like blue stragglers. The pressure of this shared proximity does not cause chaos. Instead, it sustains a kind of stillness. Gravity pulls inward from all directions, balancing motion like water held still in a bowl. Over billions of years, these cores settle into near-perfect harmony, their high densities a record of their resilience. They are cradles of starlight so compact that even telescopes struggle to resolve one sun from another. In this glowing thicket, light becomes a fabric. The cluster does not blaze with one flame, but with a million, tightly held, softly glowing, endlessly circling in a hush that has no edge. Some clusters spin slowly, a gentle turning, barely perceptible, across millennia. To us, a cluster may appear still, suspended in space, unmoving against the starry background, but inside, motion flows like breath through a sleeping body. Many clusters rotate, not quickly, not with violence, but with a long, slow turning that takes millions of years to complete a single spin. It is not a spin like a wheel, rigid and unified. It is a subtle drift, a collective lean, with stars dancing in elliptical paths around a common center. This rotation affects the shape of the cluster ever so slightly. It can cause a gentle flattening at the poles, a hint of elongation, like a drop of water held in balance. Astronomers detect it by tracing star motions, measuring shifts over decades, comparing patterns in proper motion. The spin is a memory, a leftover rhythm from the cluster's birth when swirling gas collapsed into light. That early momentum never truly vanished. It softened, slowed, but still persists. In globular clusters especially, this rotation is faint but persistent, a kind of stellar hum carried forward across billions of years. It does not disrupt their harmony. Instead, it deepens it, an undercurrent to the quiet order within. As if the whole cluster is a music box, unwinding in silence, its rotation a lullaby only the stars can hear. You won't see this motion with the eye, but it is there, always there, like time flowing sideways, like dreams gently shifting on a distant shore of light. To our eyes, they seem still, but inside, stars orbit like dancers in slow motion. When you gaze upon a globular cluster through a telescope, it appears as a motionless glow, a snowball of light frozen in the night. But that stillness is an illusion of scale and time. Within, 1,000,000 stars are in constant motion, circling the core, weaving paths through gravitational threads. These orbits are not rushed. They unfold over thousands, even millions of years. Each star is part of a vast choreography, responding to the subtle pulls of its neighbors, gliding in ellipses, loops, and swirls. Yet from Earth, this dance is imperceptible, like watching a glacier drift by a fraction of a millimeter. Even the fastest stars in these clusters complete their circuits in lifetimes longer than civilizations. But move they do, in perfect rhythm, shaped by balance. Close to the center, orbits are tighter, faster, while farther out, the stars drift more leisurely, like petals on a slow breeze. This layered movement is what keeps the cluster together, a quiet counterbalance to galactic tides and inner tensions. Occasionally, stars may pass near each other, exchanging momentum, slightly altering their paths, but there is no chaos, only endless rearrangement within the bounds of gravity. A star cluster is a time-slowed storm where motion replaces sound and velocity hides behind brightness. The longer we watch, the more we see, not stillness, but serenity in orbit, a system not frozen but gracefully turning, a cosmic lullaby where 1,000,000 lights breathe, drift, and sway in silence. Even as stars wander within, the cluster remains, a form that floats without losing itself. Clusters are living constellations, not fixed patterns etched into the sky, but flowing arrangements of motion. Stars within them do not stand still. They shift gently, orbiting, drifting, occasionally departing, and yet the shape, the character of the cluster holds steady. From afar, it remains a familiar sphere, a soft blur of gathered light. This persistence is not because the stars are locked in place, but because they are locked in rhythm. Their orbits, though varied, are part of a balanced whole. When one star moves outward, another may tilt inward. When one gains speed, another compensates. It is not a rigid structure, but a kind of breathing. The boundaries of a cluster may blur at the edges, with stars slowly slipping away into the galaxy, but the core, the heart, continues, pulsing with luminous density. This is how clusters endure for billions of years, not by resisting motion, but by embracing it. They are formed not from stasis, but from relationship. Each star's path sculpted by the gentle gravity of its companions. Over time, this shared motion creates stability, like dancers who've learned each other's pace so well. they can move freely without losing formation. The result is a shape that holds softly, gracefully, not through control, but through connection. To watch a cluster is to witness this quiet miracle, countless stars in flux, yet their union remaining intact, an eternal swirl, tender and true, held not by force, but by the memory of how they began. Stars born together carry similar songs, their spectra hum with shared chemistry. Every star carries a fingerprint in its light, a delicate spectrum of absorption lines that tells the story of its makeup. In a star cluster, these chemical signatures are kin. Like siblings sharing traits of voice or expression, stars formed from the same cloud bear the same elemental ancestry. They shine not just in brightness, but in memory, the memory of a shared beginning, of hydrogen, helium, and trace metals swirled in the same womb of gas and dust. When astronomers study their light, they find patterns, identical curves, familiar notches, repeated whispers in starlight that say, "We are from the same place." These fingerprints confirm what the eyes cannot see, that even if a star has drifted to the cluster's edge, it still belongs. It was shaped by the same breath, born in the same flare of collapse and heat. Over time, some stars may change slightly. They may forge heavier elements in their cores or shed outer layers in wind and age, but the foundational notes remain. That shared chemistry binds them long after gravity begins to loosen its hold. In some clusters, this uniformity is nearly perfect. In others, subtle differences hint at layered generations or unusual histories. But always, the light tells a story. A cluster is not just a grouping, it is a harmony. Its stars sing in chords of iron, carbon, and calcium resonating across the void, a quiet, glowing chorus of ancient origin, still holding tune after billions of years. Not all siblings are the same. Some form faster, hotter, or with a touch more metal. Even when stars are born side by side from the same cloud and moment, they do not emerge as clones. Differences begin in the cradle, slight variations in mass, in temperature, in how much of the raw material each star gathers as it forms. Some stars ignite their fusion earlier, burning hotter and bluer. Others take longer, slower to stir, cooler to shine. These small divergences deepen over time. The heavier stars race ahead, evolving faster, swelling into red giants or collapsing into remnants long before their smaller siblings shift at all. Even the metals, those elements heavier than helium, may vary by fraction, affecting a star's temperature, its light, its lifespan. These differences are subtle but significant. They allow astronomers to map out a cluster's life, to read its age like rings in a tree. On a diagram, the stars align in a graceful curve, but at the edges, some deviate, not because they don't belong, but because they've aged differently. It's a reminder that even within unity, uniqueness blooms. A cluster is not sameness. It is a constellation of personalities, each star shaped by nuance. Just as no two lives unfold the same way, no two stars, even born together, share the exact fate. And yet, they remain bound, held by gravity, by shared origin, by the quiet knowledge of where they came from. In this gentle variance lies beauty, a sky full of kin, each one whispering its own shimmering version of the same beginning. Some clusters contain surprises, different generations, layered like starlight sediment. At first glance, a star cluster seems simple, a group of stars born together, aging together, but look closer, deeper, and the simplicity dissolves. Some clusters especially the ancient globular ones, reveal multiple populations of stars, layers of birth hidden within the same celestial sphere. One group may be older, fainter, redder. Another, slightly younger, brighter, perhaps with different chemical fingerprints. It's as if the cluster breathed twice or thrice, drawing from its own remains to create again. These populations speak of a complex history where the first stars formed, lived, and died, seeding the cluster with new material from which new stars rose. It challenges the idea of clusters as singular events. Instead, they become cosmic palimpsests, overwritten with each era, while still retaining the whispers of the one before. Astronomers unravel these layers using light and mathematics, studying subtle curves in data that reveal not just age, but sequence. It's a puzzle with no easy answers. Why did some clusters form in waves, while others did not? What conditions allowed this recurrence of birth? Some believe external gas clouds merge with the cluster, sparking new creation. Others point to unusual gravitational dynamics. Whatever the cause, these multiple populations transform clusters into stories, not just of formation, but of reformation, places where the universe practiced making stars more than once. They are no longer just families, they are dynasties. Generations woven together, shimmering in silence, carrying the layered echoes of multiple dawns within a single glowing sphere. A few refuse to fit the pattern. Too massive, too mixed, too strange. While most star clusters follow familiar rhythms, single bursts of creation, cohesive light, shared chemistry, some stand apart. They're too heavy, or their stars too diverse. Their orbits defy typical paths. Their chemical signatures hint at histories that don't quite match. These are the rule breakers, the outliers, the clusters that tell a different story. Some hold stars of wildly varying ages, suggesting they didn't form in a single wave. Others contain more mass than a cluster should reasonably hold, bordering on the threshold of being galaxies themselves. They confuse our categories. They blur the line between cluster and remnant, between birth and aftermath. In these oddities, astronomers see hints of galactic cannibalism. Clusters formed not in solitude, but in violence. Perhaps they were once the hearts of smaller galaxies, torn free in ancient collisions, their outer stars stripped away, leaving only the dense core behind. Their diversity becomes a signature of trauma, evidence that they've lived through upheaval and emerged altered. Studying them stretches our definitions. They remind us that the cosmos, like life, does not always obey its own rules, that even among the serene gatherings of stars, there are rebels, survivors, enigmas. These clusters do not speak in a single voice. They hum in dissonance, in chords that are rich and strange, and yet their light still shines steadily. Even broken rules make beautiful patterns in the sky. Even the exceptions find a way to belong, held by gravity, anchored in mystery, pulsing quietly against the known. Omega Centauri may be more than a cluster. Some believe it's the leftover heart of a swallowed galaxy. It hangs in the southern sky like a chandelier of ancient light. Omega Centauri, the largest and brightest globular cluster visible from Earth. But it's not just its size that stirs curiosity. Within its dense core are signs of complexity, of layered histories that go beyond what a simple cluster should contain. Its stars span a wide range of ages and metallicities. Some shine with youthful vigor, others with the cool hush of great age. This diversity, unusual for a single cluster, suggests something deeper, that Omega Centauri may not be a true cluster at all, but the remnant core of a small galaxy consumed long ago by the Milky Way. Stripped of its stars, gas, and shape, what remained was its dense, glowing heart, still intact, still turning, still luminous. This theory gives it a quiet grandeur. To look at Omega Centauri is to peer into the aftermath of a cosmic meal. It reminds us that galaxies grow by merging, and in their hunger, they sometimes leave crumbs behind. Clusters like this, too complex for their category, too massive for their kind. It orbits our galaxy like a survivor, bearing the scars and songs of a long ago home. Through telescopes, it dazzles, a million stars condensed into a single glowing sphere, but in truth, it may be a shattered world's memory, pulsing still, a heart without a body, a galaxy reduced to light, and yet it endures quietly, magnificently, refusing to disappear. Hidden behind dust, Terzan flickers. Its stars tell of ancient formation, caught between cluster and core. Deep within the crowded bulge of the Milky Way, Terzan hides behind veils of interstellar dust. Invisible to the naked eye, it was long overlooked, just a dim flicker in the noise. But through infrared eyes and deeper study, something extraordinary was found. Terzan 5 is not like other clusters. It holds two distinct populations of stars, separated not just by age, but by origin. One group is old, over 12 billion years. The other, significantly younger, rich in metals. Their presence together suggests that Terzan 5 once had the gravity and structure to hold onto gas and form stars again. That's rare. It means this object wasn't merely a cluster. It was once more massive, more complex. Some scientists believe it is a remnant of the galaxy's earliest building blocks, a fossil fragment from a time before the Milky Way took shape, a surviving shard of what might have become a galactic core. Now, it sits like a time capsule embedded in the galactic bulge, whispering of ancient eras and stellar fire. Terzan 5 is a place where past and present coexist, where the first lights of the universe still mingle with later echoes. Observing it is like looking at a broken clock that still ticks, its hands pointing not just to now, but to before. It reminds us that even in the heart of a modern galaxy, the echoes of its formation still glow, quiet, dusty, and very much alive. NGC 2808 holds multiple generations, stars of different ages all gathered in one celestial cradle. This cluster defies simplicity. NGC 28, nestled in the southern sky, does not merely contain stars, it contains eras. Through careful measurement, astronomers have found not one, not two, but at least 3 distinct populations of stars, layered within the same space. It's like a time lapse of cosmic birth frozen in place. The stars don't just differ in brightness, they differ in age, in composition, in the story they tell. Each generation pulses with its own rhythm, its own subtle chemistry. This diversity suggests something rare, that NGC 2808 formed in multiple waves, possibly reusing the gas expelled by earlier stars to create new ones. But how did it hold onto that gas? Clusters aren't usually massive enough to trap the material needed for rebirth. NGC 2808 must have been heavier once, perhaps part of something larger, a fragment of a dwarf galaxy or a nucleus that survived cosmic upheaval. Looking at it is like watching a family portrait in which grandparents, parents, and children all stand side by side, glowing at once. The cluster becomes a kind of stellar archive, each layer of stars a chapter added after the last. It doesn't just mark a moment in time, it records a sequence, a resilience, a recurrence. NGC 2808 reminds us that even in the vast quiet of the sky, repetition and reinvention are possible, that light can return to the same place more than once, and that stars, like stories, sometimes begin again. Perhaps these clusters are not clusters at all, but shattered centers, still glowing after the rest has gone. Among the stars that drift quietly in our galaxy's halo, some clusters seem too complex, too massive, too ancient to fit neatly into the definition of a star cluster. Their stars are varied, their masses immense, and their motions peculiar. These may not be clusters in the traditional sense. They may be remnants, the ghostly cores of galaxies long since devoured by the Milky Way. Stripped of their spiral arms, their gas, their outer stars, only their hearts remain, dense, glowing, gravitationally intact. Like embers from a fire long gone cold, they float through space with the memory of something larger. We see them as clusters because that's what's left, but beneath the light lies history, evidence of collisions, of mergers, of galaxies, consumed in the slow hunger of cosmic time. Studying them blurs the line between cluster and galaxy, between what was built and what was broken. These remnants carry secrets in their chemical compositions, in the motion of their stars, in their unusual populations. They are both survivors and casualties, not destroyed, but transformed. To gaze upon one is to glimpse a long-vanished world, a place that once spun with its own light, now reduced to a jewel adrift. And yet, there is beauty in that endurance. These stellar remnants may be fragments, but they still shine, still orbit, still whisper. In the silent sky, they remind us that even what is lost can leave behind something luminous, something that lasts. From Earth, they appear as smudges, tiny condensations of light, barely distinguishable to the naked eye. At first glance, a star cluster may look like a faint blur against the dark canvas of the night. No brighter than a whisper, no sharper than a breath on glass. But even the gentlest glow hides an extraordinary truth. That small haze may contain hundreds of thousands of stars, bound together in a slow, shared orbit through space. Through binoculars or small backyard telescopes, the smudge sharpens into sparkling dust, specks of light resolved, like glitter strewn across the void. And with more powerful lenses like those aboard space telescopes, the smudge becomes a cathedral of starlight, each dot a sun, each sun a world. From Earth, we study their brightness, their position, their color. We map their motion. We watch how they shift over time. In those, movements and hues are clues to age, to distance, to origin. Astronomers chart them, catalog them, name them, messier numbers, NGC labels, coordinates pinned to the sky. Yet for all this science, there remains a softness because, to the unaided eye, clusters still appear as they did to our ancestors. Subtle, roundish flickers, barely there. Ancient peoples gave them names, folded them into stories, traced their paths through myth and memory. And even today, when we can resolve their stars and measure their temperature, that dreamlike quality persists. There is something humbling in how clusters appear from here, small, serene, unreachable, a reminder that even the grandest gatherings of suns can look like nothing more than a whisper of light. Infrared reveals what dust conceals. Through these longer waves, clusters bloom into view. In the visible spectrum, the universe hides behind curtains of dust, thick clouds that obscure the youngest clusters, the densest cores, the most crowded cradles of stars. But in infrared, the story changes. What was once opaque becomes transparent. Dust no longer blinds, but gently glows, and through these soft, reddish wavelengths, astronomers peer deeper into the galactic womb. Hidden clusters emerge, still swaddled in gas, their stars just beginning to shine. Light, stretched and softened, reveals what human eyes cannot see. Embedded clusters in nebulae, cores glowing behind the thick lanes of the Milky Way. Even distant galaxies, cradling their own starry families. Infrared telescopes, like Spitzer and the James Webb Space Telescope, open new windows into these mysteries. They don't just see the stars, they see their surroundings, their birthplaces, their veils. This kind of vision is not sharp or harsh, but gentle. It renders the universe in warm tones and quiet outlines, mapping not just brightness, but heat, the warm breath of newborn stars, the slow cooling of dust around them. In this way, infrared doesn't replace what we see. It completes it, adds depth, adds time. Looking at a cluster in infrared is like seeing the heart of something, not just its surface, but its soul. And in that soul is the soft glow of beginnings, silent, hidden, beautiful, waiting only for the right kind of eyes to notice. The Hubble Space Telescope peers into their hearts, resolving stars once blurred into brightness. From Earth, a star cluster's center can seem like a single flare, a smear of brilliance where too many stars overlap. But Hubble, floating above the atmosphere, sees more clearly. With its steady gaze and patient eye, it reaches into the very core, separating what once looked like one into thousands. Each point of light, once lost in the blur, becomes distinct, a star with its own color, motion, and story. The telescope's silence is part of its power. In orbit, there is no wind, no interference, no distortion, just the quiet attention of a lens and mirror tuned to the stillness of space. Through it, we witness the impossible density of a globular cluster's center, a crowded ballroom of stars, each moving at its own pace, pulled and nudged by neighbors too close to ignore. Hubble's vision has shown us not only the stars, but the dynamics, collisions, binaries, even hints of hidden black holes. And yet, it doesn't just capture data, it captures beauty, images filled with blues and ambers, scattered like gemstones, swirls of old light, layered deep with time. These views aren't just clearer, they're deeper. We see the age, we see the closeness, we see the fragile structure that has held together for billions of years. With Hubble's eye, the core is no longer a mystery. It is a moment of clarity where chaos becomes shape and brightness becomes intimacy. 1,000 suns, each resolved, each gently shining in place. Gaia maps their motion, every star in a cluster, measured, traced, followed through the dark. Gaia does not look at the stars the way a human does. It listens for movement. It watches the sky as it turns again and again, marking each star's subtle drift. With breathtaking precision, it tracks how clusters shift through space, not just as a whole, but as individuals within. Like watching a murmuration of birds frozen in slow time, Gaia follows every slight flutter, every graceful loop. In the past, we could only guess at a cluster's trajectory. Now, we see its stars in motion, arcing, curving, expanding, sometimes tightening. From these motions, Gaia builds maps, not static ones, but living maps, motion charts, three-dimensional tapestries of time. It shows us how clusters orbit the galactic center, how some trail tales of escaping stars, how others hold tightly to their oldest members. The spacecraft measures distances too, not by triangulation, but by parallax, using Earth's own orbit to detect the slightest shift. From these tiny changes, great truths emerge: distances, velocities, relationships. Gaia's data is like a breathing map of the galaxy, and within it, clusters stand out like constellations of motion. We begin to see not only where they are, but where they've been and where they're going. The sky, once thought fixed, becomes fluid, and in that movement, we find connection. Clusters are no longer just points of light. They are travelers, ancient wanderers, and Gaia, with quiet certainty, watches their paths unwind. Beyond our galaxy, clusters still bloom. The large Magellanic Cloud cradles them like ornaments in its arms. This nearby companion to the Milky Way is not just a faint smudge in the southern sky. It's a galaxy with its own life, its own rhythm, and its own clusters. Some are young, their stars still shimmering with the warmth of recent birth. Others are old, glowing softly in rounded globes. The Large Magellanic Cloud, or LMC, is irregular, a little lopsided, its shape twisted by interactions with our own galaxy. But within that asymmetry lies grace. Clusters scattered, like lanterns caught in a slow spiral dance. Because the LMC is smaller and closer than many other galaxies, we see its clusters more clearly. We watch them form, we witness them age, and in doing so, we glimpse a kind of mirror to our own galaxy's past. Some clusters in the LMC are among the youngest we know, caught in stellar nurseries still wrapped in gas. Others have already begun to dissolve, their stars meandering outward in soft streams. These clusters teach us how galaxies nurture and let go, how gravity stitches and unravels, and how light, no matter how far, still arrives. Observing the LMC's clusters, we're reminded that starbirth isn't rare. It's a rhythm echoed across the cosmos. The LMC holds its own symphony, bright, evolving, ancient, and in the quiet of night, when you look south and see that patch of haze, know that within it are star clusters breathing in their own gentle time, turning slowly in a galaxy beside our own. In faint dwarf galaxies, clusters flicker like memories, their light soft, their motion slow. The sculptor dwarf galaxy is quiet. It glides through the outskirts of our galactic neighborhood, dim and understated, like a forgotten note in a cosmic song. Within it, clusters reside, not the blazing hubs of young stars, but old, faint collections of light. They move slowly, as if memory itself takes its time. These clusters, preserved in the galaxy's stillness, offer a rare glimpse into the quiet side of cosmic evolution. Dwarf galaxies, like sculptor, are fragile. They are easily shaped, pulled, and sometimes broken apart by the gravity of larger galaxies. Yet, within their gentle embrace, clusters have survived. They are less crowded, less vibrant, but no less meaningful. Their stars burn softly, revealing clues about what the early universe might have looked like in miniature. In sculptor, every flicker is precious. Every spectrum tells a quieter story. These clusters have fewer stars, but perhaps more space between them, a kind of contemplative distance, as though they're resting in solitude. Astronomers peer into this galaxy and find time slowed, not in reality, but in feel. The pace is different, the history deeper. Watching the sculptor dwarf's clusters is like reading an old journal. Faint ink, slow lines, and tender pages. They don't shout, they whisper, and through those whispers, we hear echoes from a time when galaxies were young and light had just begun its patient journey through the dark. clusters are not just ours. They hang like pearls around galaxies near and far. Scattered across the cosmos, wherever galaxies glow, clusters follow, small gatherings of stars, like punctuation in a vast celestial sentence. In spiral galaxies, they line the arms in delicate strings. In ellipticals, they form halos, suspended in soft shells around a glowing core. Some are bright and easy to find, while others are dim, tucked into shadows or hidden behind curtains of interstellar dust. From the Andromeda Galaxy to far-off realms barely visible through the deepest telescopes, clusters persist. They are not exclusive to our sky. They are a universal phenomenon, repeating in pattern and structure across space and time. When astronomers look through space-based observatories, they find them sparkling around galaxies like jewelry, tiny yet significant. They reveal the age of galaxies, their histories of collision and growth. A single distant cluster might contain hundreds of thousands of stars, all moving in harmony, all echoing a shared origin. And though they reside in foreign skies, light from those stars reaches us, crossing millions, even billions of light years to whisper across the void. It is humbling to think that what we see in our galaxy, the quiet bond of stars, is mirrored in countless others, that the instinct of the cosmos to cluster, to draw together in gravity and light, is not local. It is fundamental. No matter the galaxy, the shape, or the size, star clusters bloom, and they remind us that even in the farthest places, something gathers gently and endures. Andromeda's halo holds clusters too, silent witnesses to another galaxy's long story. High above the galactic plane, circling at great distance, are clusters of old stars, moving like quiet sentinels. In the halo of Andromeda, our neighboring spiral, these clusters glow faintly. They are not part of the spiral arms, not wrapped in dust or starbirth, but instead hang far from the chaos, suspended in stillness. Each one contains hundreds of thousands of stars, all born together before our species even had language. Their orbits are wide and slow, taking hundreds of millions of years to complete a loop. Yet despite their motion, they remain constant, like lanterns floating in a dark sea. These halo clusters are some of the oldest structures we know. They were there before galaxies grew large, before collisions reshaped their hosts. When we study the light from these ancient groups, we see a story etched in composition: low metallicity, cool temperatures, redder tones. These are signs of time, of age, of formation in an era when the universe was still settling into shape. In Andromeda's halo, clusters drift in patterns shaped by ancient mergers, the remnants of galaxies long since absorbed. Their paths trace the slow dance of cosmic history, quiet and enduring. And though they belong to another galaxy, their light spills into our view. We watch from afar, and they tell us, across space and silence, that memory endures in starlight, that even in the outermost edges, something still burns with the dignity of long light. Every galaxy seems to carry them, as if no collection of stars is complete without a few huddled close. Whether spiral or elliptical, massive or faint, galaxies seem to naturally give rise to clusters, pockets of stars held together by shared birth and gravity's quiet insistence. They form like thoughts inside the larger mind of a galaxy, delicate yet enduring. In young galaxies, clusters emerge hot and blue, their stars still burning with youthful energy. In older systems, globular clusters encircle like memories, holding a whisper of the past in tightly packed forms. Even in dwarf galaxies, small and dim, clusters can be found, tiny shining remnants of a time when the galaxy's heart still knew how to gather. No matter the shape, no matter the size, the presence of clusters tells a story of formation, of collapse, of stars that chose to stay near one another. They are not imposed structures, but natural outcomes of the way gravity works when gas cools and settles. Astronomers have yet to find a galaxy utterly without them. The logic of the cosmos seems to include them always, like punctuation, like breath. They help galaxies build structure, chart history, and maintain balance. In turn, galaxies cradle them, sometimes loosely, sometimes like secrets. This consistency across billions of light years and epochs of time suggests something fundamental, that the urge to cluster is not rare. It is woven into the very nature of galactic evolution. Where stars are born, some will remain, and those that do form these silent assemblies, always nearby, always in orbit, always whispering of their shared beginning. Even in giant ellipticals, where dust is rare and star birth is quiet, clusters remain. Elliptical galaxies are vast, smooth ellipses of old starlight, lacking the spiral arms and dusty nurseries of younger galaxies. They glow faintly with the steady radiance of stars long past their youth. In these places where new stars are seldom born and gas no longer flows freely, clusters still endure. Ancient globular clusters, suspended like memories, moving slowly through the halo. These galaxies may appear serene, even still, but their clusters are echoes of violent beginnings, of mergers, of starbursts, of the chaotic forging of structure long ago. Over time, the energy subsided, and the galaxy grew quiet, but the clusters remained. They orbit not in tidy rings, but in scattered paths that crisscross the galaxy's vast expanse. Some contain thousands of clusters, each one a compact globe of old stars shining in unison. They are resilient, their dense centers resisting dissolution even as billions of years pass. Studying these clusters helps us understand the deep past, the history of galactic collisions, the timing of early star formation, the conditions of the young universe. Though the galaxy no longer creates, it still preserves. Ellipticals are graveyards of brilliant motion, and the clusters are tombstones lit from within. They remind us that even in quiet systems, there are survivors of earlier chaos. Their light is dimmer, perhaps, but no less profound. In the absence of birth, there is memory. In the stillness, there are songs of ancient gatherings still turning in the dark. Around the brightest hearts of the cosmos, clusters orbit like fireflies circling a flame. Quasars are luminous beacons, galaxies with central black holes feeding so ravenously they outshine everything around them. Yet even in these blinding regions of energy and motion, star clusters remain. They orbit carefully, distant enough not to be swallowed, close enough to be stirred. Their presence is like a quiet song playing at the edge of a thunderstorm. These clusters may be survivors from a calmer past or new formations born in the chaotic tides of merging galaxies. Some may be stretched or heated, but they still hold. The gravity of the quasar does not destroy everything. It creates eddies, pressure waves, and regions where dust and gas can compress once more. Star formation becomes possible in the wake of that violence, and with it, clusters bloom. Around active galactic nuclei, especially in distant galaxies, seen through telescopes like Hubble and JWST, Faint glimmers of clustering stars appear. They remind us that even in the wildest conditions, the cosmos finds moments of cohesion. These clusters bear the scars of their environment, often misshapen or turbulent, but they are proof of the universe's resilience. Light blazes outward from the quasar's center, but orbiting that brilliance are small gatherings, quietly holding form. Like moths that never touch the flame, these star clusters trace slow circles, enduring despite the storm. They show us that beauty can survive even at the edge of chaos, and that the cosmos always finds a way to gather light. Some are barely there, whispered concentrations of light, only found through patient watching. Not every cluster is bold. Some do not shout with blue giants or burn with ancient red cores. Instead, they are delicate, diffuse, dim, almost invisible against the noise of the galaxy. These are the faintest clusters, discovered only through deep surveys and careful subtraction of background stars. They may contain just a few dozen suns, loosely held, drifting on the edge of recognition. Yet they are real and precious. Their faintness makes them fragile, vulnerable to disruption by passing clouds or tidal forces, but the fact that they still exist speaks of quiet perseverance. Some of these clusters may be on the verge of dissolution. Others may have formed with just enough gravity to hold, like a breath that never fully exhales. They are difficult to classify, living on the boundary between cluster and moving group, between gathering and coincidence, but they hold clues. Their composition, their motion, their location, each tells us something about the quieter paths of star formation, the subtle processes that happen beyond the spotlight. They remind us that not all truths blaze like quasars. Some whisper in low light. Some require patience, silence, and care to find. And when found, they shift our understanding. The sky is full of these quiet places, not empty, just unnoticed. And in these dim gatherings, we see another side of the universe, gentle, understated, but still woven with gravity, with history, and with the soft echo of stars born together. What defines a cluster? At the edge, the line blurs. Some are nearly galaxies themselves. Ultra-compact dwarfs, or UCDs, sit in a liminal space, too large and massive to be typical clusters, too small and faint to be full galaxies. They challenge our categories. At first glance, they appear like oversized globular clusters, dense with stars and glowing steadily. But look closer, and something shifts. Their structure is more complex. Their mass is greater. They may even hold dark matter or central black holes, traits more common to galaxies. Some astronomers believe UCD are the stripped remnants of dwarf galaxies, their outer stars pulled away by tidal forces, leaving only the core behind. Others suggest they formed unusually large from the collapse of giant clouds of gas. Either way, they occupy a strange middle ground, a testament to how the universe doesn't always draw clean lines. They blur the boundary between group and galaxy, cluster and remnant, starry knot and ancient fragment. Studying them helps us understand galactic mergers, tidal stripping, and the evolutionary paths of cosmic structures. They are fossils of interactions, scars of past gravitational encounters. In them, we glimpse the violence that shaped the skies and the resilience that allowed some structures to remain. They are compact, luminous, and rare, and like all clusters, they speak of cohesion, but theirs is a deeper kind, forged in compression and chaos. They remind us that labels are conveniences, not absolutes, that in the cosmic story, Some chapters resist classification, and that the sky often writes in nuance, not certainty. In computers, we simulate their motion, watching millions of stars swirl in silence. Human eyes cannot follow a star across a million years, but computers can. Through simulation, we create digital star clusters, virtual skies where gravity plays out in slow motion. With algorithms and particle models, astronomers track the motion of thousands, sometimes millions, of stars interacting over billions of years. These simulations reveal the hidden ballet within clusters, stars tugging gently on one another, binary pairs forming and dissolving, central densities rising, edges thinning. We can watch core collapse, tidal stripping, mass segregation, and even the formation of intermediate black holes. What appears static in the night sky becomes vibrant and alive on screen. Each frame a century, each second a spiral. These models help us test theories about formation, evolution, survival. They let us rewind and fast forward the universe, exploring how clusters change under different conditions. Do they survive galaxy mergers? How do binaries affect stability? What happens when a black hole forms in the core? Simulations offer answers and raise new questions. They bridge observation and theory, turning math into motion, equations into experience. Though no simulation is perfect, each one teaches us a little more. In the digital quiet, we see the dynamism of the real sky. We see that even the calmest clusters are alive with movement, and we remember that beneath stillness, there is always motion. The stars dance, even when we cannot see it, and in these virtual realms, we are allowed to witness their steps. With equations and code, we watch clusters form, evolve, and sometimes collapse. The story of a star cluster can be told through gravity, but it's a long and delicate tale. When we simulate collapse, we begin with a cloud, a digital sea of particles representing gas, dust, and early stars. Slowly, under the influence of gravity, the cloud begins to shrink. Filaments form, knots emerge, and stars ignite. This early stage is messy, filled with turbulence, fragmentation, and feedback. Some stars grow massive and hot, pushing against the gas with radiation and winds. Others stay small, caught in the quiet shadows. Over time, gas is expelled, leaving behind a newborn cluster, loosely bound, vibrant, chaotic. In the simulation, we let time pass. Stars interact gravitationally. The cluster breathes, contracts, stretches. Mass segregation pulls heavier stars inward. Light ones drift out. Core collapse can occur. The center tightening, heating, becoming unstable. Binary stars play a crucial role, injecting energy back into the system and preventing full collapse. Without them, the cluster might implode or evaporate entirely. Some simulations add external forces, tidal pulls from the galactic disk, encounters with clouds, or mergers with other clusters. Each variable changes the story, but always gravity writes the script. Collapse, survival, dissolution, it's all encoded in motion and mass. These models help us understand what the sky won't show in real time. They compress epochs into hours, and in their silent precision, we glimpse the inner workings of cosmic structures. The fall, the balance, the loss, all captured in quiet numbers that move like stars. Cores are crowded, stars pass close, pull each other gently, change course like whispers changing tone. In the heart of a dense star cluster, space is a negotiation. The distance between stars narrows to a cosmic intimacy, not light years apart, but fractions of a parsec. Here, gravitational interactions are not rare but routine. Stars weave through one another's pool, subtly deflecting paths, forming temporary partnerships, or slingshotting each other away. Binary systems form, merge, or get disrupted. A quiet chaos rules, slow but ceaseless. Over time, heavier stars sink inward, a process called mass segregation, thickening the core further. In some clusters, this leads to core collapse, where the center tightens and grows unstable. But binary stars act as pressure valves, injecting energy into the core and halting the collapse temporarily. This is what the cosmos does. It gathers softly in light and time and rest. From the smallest particles to the grandest galaxies, the universe leans toward togetherness. It draws things in, not always forever, not without change, but with a kind of tender pull. Hydrogen atoms find each other and form clouds. Clouds collapse into stars. Stars huddle into clusters. Clusters drift in halos. Halos surround galaxies. Galaxies join in groups, and those groups into filaments that stretch across the dark like threads in a vast cosmic loom. This pattern is everywhere, not in rigidity, but in rhythm. In a universe ruled by expansion, gathering still happens, quietly, beautifully. And these clusters of stars, of galaxies, of thoughts, they are not accidents. They are the resting points, the places where time breathes slower, where light stays near. You are watching one long exhale of creation. And inside that breath, the universe pauses to hold itself just for a while. A star cluster is not just a scientific fact. It is a gesture, a cosmic lullaby, a moment of cohesion in an ocean of motion. Tonight, you've drifted through that quiet pattern, through families of stars, ancient halos, stellar cradles, and fading echoes. You've moved through gravity's soft arms and light's layered warmth. And now, as you rest, remember this. The universe does not only expand, it also embraces, it clusters, it gathers. And in that gathering of stars, of dreams, of slow thoughts, you too are held. Sleep gently now. The sky remembers, and so do you.